Hello, everybody. Today we're going to talk about some more log properties, ways that we can combine and expand logs out, and then how we can get them in our calculators. So just like algebra has properties, commutative, associative, identity, logarithms have properties as well. They help us solve equations involving logarithms. So we have our product rule here. Log base b of m times n. Remember, this is multiplication. We can separate that out into log base b of m plus log base b of n. So our first example, log of 7x. First of all, what's the base? Because there's no base written there. Well, it's base 10. So if I'm separating this out, I have log of 7. Remember, we don't write base 10, plus log x. Right at that multiplication symbol, or where it would be if we wrote it, is where we start the next part of plus log. The next example, log base 2 of 3 times t. We have log base 2 of 3. Now we add plus log base 2 of t. So we separated out the t, our variable, into something where we might be able to now solve for t. The quotient rule. If I'm dividing, I rewrite dividing as subtraction. Hopefully these look a little bit familiar from our exponent rules. Remember, for multiplying like bases, we add exponents. If we're dividing like bases, we subtract exponents. And that's where these properties are coming from. So in our first example, we would write log base 7 of m minus log base 7 of 3. Remember, order matters in subtraction. The numerator or the value on top has to be first. Our second example, we have log base 5 of c minus log base 5 of 25. Our exponent rule says that when I have a number to an exponent, that exponent shoots to the front and is multiplied. Again, kind of going back to our exponent rules, when we had two exponents next to each other, we multiplied them. And so we're doing something similar to that, but we're multiplying it to the log. So in our first example, this 5 is an exponent. It's going to drop down to the front, so it's 5 times log base 3 of r. The 2/3 is an exponent. That drops down to the front, so we have 2/3 times log base 4 of v. Now we're going to combine those together. So when we're expanding logarithms, then we're taking this very small expression right here, and we're writing it out into something much larger so we can start pulling apart our variables and maybe solving for them. On the top of my fraction, my numerator, I have 5 times x to the 3rd. So we have log base 6 of 5. Remember, multiplication is adding. Log base 6 of x cubed. Then we're dividing, so we subtract log base 6 of y. We have one more property to take care of here, and that's our exponent of 3. That means to drop down to the front. So log base 6 of 5 plus 3 log base 6 of x minus log base 6 of y. That would be our final expanded form. For our second example, the base here, remember it's not written, is base 10. And this is 3 times x to the 4th. So to expand that out, I have log 3. Remember, multiplication changes to addition, plus log x to the 4th. The last part of this takes our 4th power, our exponent there, and drops it to the front. So we have log of 3 plus 4 log x. And that would be our final expanded form. We're going to skip this bottom part and head to the back side of your notes. Expanding. So we have log base 6 of 3. That's 3 times x to the 4th, so that changes to addition. The 4 drops down to the front. Log base 6 of x. Remember, logs and natural logs are the same inverse. It's just that natural logs always go with base e. So our base in number 6 is e. And we have the natural log of 5. Division is subtraction. And then I've got multiplication going on down there, so I want to make sure I group that together. The natural log of 12 plus the natural log of x. Last but not least is the formula that we've been waiting for, the change of base formula. And remember, we're going to want to memorize this, especially for those of us with calculators who don't have log base on it. So remember, we said that I can type log 8 in my calculator because this base is 10 and my calculator is base 10. But if I wanted to do log base 2 of 8, I cannot type that in my calculator. So the change of base formula allows us to change this in our calculator, and it's log A divided by log C. The base stays in the basement or the bottom of our fraction. So rewriting these to get them in the calculator, we have log 8 divided by log 5. 5 is the base, it stays in the bottom. Type that in my calculator. Now remember, when you hit log, most of us, a parenthesis is going to pop up. It is extremely important that you close the parenthesis after the 8 before you hit the division key to do log 5. We should also close that bottom parenthesis, and we should get 1.29. We're rounding to the hundredths place today. So log 14 divided by log 8. Log 9 divided by log 26. Remember, we don't care which one is the bigger number in terms of 26 is a bigger number than 9. What we care about is what's the base. The base is the itty bitty number, which is 26, and that has to stay in the bottom. Number 12, log 30 divided by log 12. When you come to class tomorrow, make sure that you have found the 3 answers for examples 10, 11, and 12, rounded to the hundredths place. And that's what we'll check for credit. Have a great night.